Okay, now here in example 3, there's a little bit, it's a little bit different than what we've been doing. Notice the area underneath the curve of f of x equaling x squared is not a perfect rectangle. All right, it's an irregular shape. But you watched a couple videos yesterday. In order to approximate this area, we're going to use rectangles. Specifically in this example, we're going to use 6 rectangles to approximate the area of the region below f of x equaling x squared over the interval from 0 to 3. Now, the interval is from 0 to 3, and if there's 6 rectangles, alright, so if you do 3 divided by 6, you're going to get a base of 1/2 for each of these. Alright, so you want to copy down this chart here. Alright, I broke down the 6 subintervals, or 6 rectangles. Alright, I wrote down the base for all of them. We just said that that was 1/2. And now we need to find what the height is. We are going to use the right boundary of each rectangle to approximate the height. As a result, you can see that we're going to have excess area that we're going to be counting in. So this area is going to be an over approximation of the true area. Alright, so in order to find what the height is, okay, so that's 1/2, there's 1, there's 1.5, there's 2, there's 2.5, and there's 3. We want to know what the height is at each of those spots, okay, and then we would do our base times height to get the area. So we would want to know what these heights are. So in order to do that, what we're going to do is plug in our x coordinate, alright, into our function to get what our y coordinate is at that point. Alright, so let's do that. Okay, so to find what our height is, we're going to take 1/2, we're going to find f of 1/2, so that's going to equal 1/2 squared, which is equal to 1/4. Then for the next one, we're going to find f of 1, that's going to be 1 squared, and that's going to be 1. F of 3/2, so that's going to be 3/2 squared, and that's going to give us 9/4. F of 2 is 2 squared, and that's 4. F of 5/2, that's 5/2 squared, that's going to give us 25/4. And then f of 3 is 3 squared, and that's going to be 9. So what I did was I took each of these endpoints and I plugged it in for x to get what our y coordinates were. So let me erase. I want to just make sure we're completely clear what we did. So we took this x coordinate 3, we plugged it into our function to get what the y coordinate is of that point right there. So that point right there is 3, 9. This point right here, let's keep it, that was 2, 4, and so on. Okay, so now we have our height. Now we can calculate the area. So we're going to do 1/2 times 1/4. That's going to give us an 1/8. Let's put this in let's do decimals because we're going to be adding these all together to get an area. So 0.125, and then we got 1/2 times 1. That's going to be 0.5. One half times 9/4. 1.125. 1/2 times 4. That's going to be 2. 1/2 times 25/4. 3.125. And 1/2 times 9, 4.5. Okay? Alright, take all of these, add them up, and our total area will be approximately 11.375. Okay, now this is an over approximation of our true area because we used the right bound of these rectangles to estimate our height.